Welcome to module D, lecture 4. In this lecture, we shall talk about another growth factor based method, which is called Furness method, and also we shall discuss general limitations regarding application of growth factor based methods. In lecture 3, we discuss two specific methods which are also growth factor methods. They are called Detroit methods and Frater model. In each case, we discussed how these methods can be applied, and we took example problems to demonstrate the application of these methods for getting the future or horizon year or design year OD matrix to match the row total and the column totals. This lecture we will discuss about Furness method, which is again an iterative process, and what we do here, the estimates of future traffic originating and terminating at each zone are required, yielding origin and destination growth factors for each zone. So, what we do, suppose we take the matrix, now the column total has to match with the future column total and the row totals have to match with the future row totals. So, we take a column and then see what is the present total and then what is our target total. Then target total by present total, that is the factor, that is the destination end growth factor, and we multiply all the cells in that column with that factor, growth factor. Similarly, we do it for each destination zone. So, if there are n destination zone, so then every column we find out the growth factor and then map or multiply each cell in that column with that growth factor value. Then we take the next column, then we take the next column, like that all columns in that matrix we apply the growth factor. Now, obviously, what will happen because of this, the column totals will match perfectly, but obviously, the row total will not match. But the final matrix what we should get, we expect the row totals as well as the column totals to match reasonably. So, what we do? We go to the next iteration, and in that iteration whatever we did for each column, now we do the same treatment for each row. So, we take a row, we now see what is the row total we are getting and what is our target row total for each zone, then calculate the growth factor and then multiply each cell of that row with that particular growth factor. So, what will happen? Now, the row total will be exactly, for that zone will exactly match with the target row total. We do the same thing for each row. So, again now then all the production totals or at the origin ends the totals will match, but in that process the column totals will now get distorted, right, because we have adjusted the row totals. So, again we will come back, we will now again adjust the column totals as we did in iteration 1. Then again we will go and adjust the row totals as we did in iteration 2, and this process will continue. How long it will continue? Again it depends on what is your acceptable error level. So, you set that acceptable error level, and maybe we can set something that when the growth factor, calculated growth factor is less than plus minus say 5%, that means or 2%, whatever you would like to set. So, Accordingly, you can set a value that may be okay 1.02 to 0.98 or 1.01 to 0.99, that is the range which is acceptable. Accordingly, the number of iterations will happen till you get your expected or targeted accuracy. So, that is what I said here. Let us look at the slide again. The traffic movements are made to agree alternatively with future with the traffic movements are made to agree alternatively with future traffic operating in each zone and estimated future traffic terminating in each zone until both conditions are roughly satisfied. So, that is what it is. The remaining thing what I said are explained here. So, the trip distribution matrix for the base year is obtained. Then from the predicted future origin and destination value, the origin and destination growth factors are calculated for each zone as I explained earlier. Then for each column of the matrix is scaled by appropriate destination growth factor such that the column totals become equal to the predicted column totals. So, the column will match perfectly, but the row totals would not match with the predicted totals as usual. So, therefore, similar process should be applied next to the row scaling, and this process will continue. So, match the column totals, then match the row totals, match again the column totals, match again the row totals. Like that we will continue in an iterative manner till we get the required accuracy or expected accuracy. Let us take an example to explain this more clearly. This is the given OD matrix in the base year. You can see the cells 45, 60, 70, 55 and the total present row total is 230 for zone 1 or origin zone 1. Then origin zone 2 100, 90, 85 and 10. So, total row total is 385. Next one is 310. The zone 4 origin zone row total is 305 and total we have 1230 trips which are presently distributed now. Interestingly, in this example problem Tij is not equal to Tji. So, you can see 1 2 is 60, but 2 1 is 100, 1 3 is 70, 3 1 is 65. So, it is not a matrix where the Tij equal to Tji. And we know what will be our future productions and attractions of each zone that are given. Okay. So, there these values are 375, 450, 630 and 530. Okay. In this example, there the target totals are given same, okay, quite possible, and we need actually 1985 trips to be distributed in the future. So, we need to update this given matrix in such a manner that the total trips become 1985 and the row totals and column totals become 375, 450, 630 and 530 for zone 1, 2, 3, 4 and 4 respectively. So, that is what we need to do. So, what we do first? First we calculate what is the present column total for column 1, 265, what is the target total 375. So, then what is the growth factor 375 divided by 265. Okay. So, you get the factor as 1.42. Now, each cell in this column I would multiply it by 1.42. So, 45 into 1.42, 100 into 1.42, 65 into 1.42, 55 into 1.42. Similarly, for column 2, the present one total is 320, the predicted total is 450 and we calculate a value of growth factor as 1.41. So, each cell in this column 60 into 1.41, 90 into 1.41, 75 into 1.41 and 95 into 1.41, like that we will do. So, what will happen in that case? The column totals for each zone 1, 2, 3 and 4 will exactly match with the target column total of zone 1, 2, 3 and 4, right. Let us see that we have done it. So, exactly now my column totals are matching very nicely, okay. But then the row totals, are they matching? No. In the first case, yes, somewhere instead of 374 and 375 there is a close match incidentally, but look at zone 2, 615 and 450, 504, 630. So, they have not matched, they did not match. So, what we will do now? Now, we will go for the row level operation as I explained. So, what I will do? Let us calculate the growth factor 375 divided by 374. So, we have say 1. Then 450 divided by 615. So, 0.73. 630 divided by 504, 1.25. 530 divided by 491, 1.08. Now, what we will do? First one is 1. So, each cell will be multiplied by 1, each cell in row 1, each cell in row 2 will be multiplied by 0.73, each cell in row 3 will be multiplied by 1.25, each cell in row 4 or zone 4 will be multiplied by one factor 1.08. So, then what will happen? We expect them the row totals to match perfectly. Let us see, that is what has happened now. Now, you can see the row totals are giving you very nice and perfect match. But then what is happening? Let us look at the column total. The column total which were all adjusted very nicely, now they got somewhat distorted. So, the column totals are not matching as the row totals are matching now, not to that level, right. So, what we do? We repeat this whole procedure. Again we calculate the growth factor for each column, okay, and multiply each cell of that column with the respective growth factors. Then again the column total will match, but then the row total will get distorted. So, again we shall come back, adjust the row total, like that we shall continue, right. And how long we shall continue? Till we get a reasonable match as per our expected accuracy. Now, with this we have more or less discussed all the models which we wanted to discuss in this course under growth factor methods. Okay. So, uniform factor, average factor, then Furness method, Frater model, okay, and Detroit model. So many things we actually different methods we have discussed. Now, what are the general disadvantages of growth factor models? Some cases we have already discussed those when we were talking about specific model, but it is important. So, I would like to discuss this once again, that what are the general disadvantages of using growth factor based models or methods. Number 1, present trip distribution matrix has to be obtained first. Every case we need to have this small Tij, that means the present trip distribution matrix must be known, because what all we are doing, we are applying a growth factor on the present Tij, which I always referred here as small Tij, to get the future or design year Tij value, which again I referred to here as capital Tij. So, we must have the small Tij, otherwise we cannot apply. So, somebody has to give you the present trip distribution matrix. Second, large scale OD studies with high sampling sizes are needed so as to estimate the smaller zone to zone movement accurately. Somebody needs to give you, where from you will get? In the field you have to measure. So, you need large scale OD studies, okay, to capture all the movement with required accuracy and as per the proper to get a proper sample. The error in original data collected on specific zone to zone gets magnified, because it is again logical for all methods that is happening. We are applying a multiplier and the multiplier is normally more than 1, right. So, because there is a growth in different zone, maybe some factor may be much higher, some factor may be somewhat lower, but all zones are generally growing. In all practical sense, every zone will grow, maybe less growth, maybe more growth, right, in normal circumstances. So, whatever is the error in the original data collection on specific zone to zone movements, those errors are getting magnified, because you are using a multiplier. Absence of measure of travel impedance imply that travel impedance will remain constant. This is a very fundamental assumptions. We know that the trip distribution depends and highly get influenced by the characteristics of the transportation system. So, the transportation systems changes significantly, either it improves or it deteriorates, okay, in both directions, there will be impact on the trip distribution, but we are not bringing the transportation system consideration in any of these methods or any of these models, growth factor based model or overall growth factor method. That means, only thing that can support this, that there is no significant change in the transportation network, which again may be not a very unrealistic assumption, because you see that every day in a city, you take a large scale city, every day road network does not change, every day big infrastructure project does not happen, right. So, it may be that we had a transportation study, we already did a transportation study and we have this Bayesian matrix, and maybe in the last 1 year or so or last 2 years or so, maybe there is practically no significant change in the transport network, no significant change in the transport network. So, we can always apply this growth factor methods to quickly update our matrix, right. So, this is the place where you have to be careful, that you know that you cannot apply this growth factor based models if there is a significant change in the transport network. But at the same time, this gives you an opportunity that if I want to use short term update, if I need to do short update of my metrics, 1 year, 2 years, 6 months, whatever you say, short period, okay. And if there is no significant change in the transportation network, so we can see the basic pattern remains same, right. So, we can use growth factor based method, and without considering the transportation network, still we are likely to get a reasonable result. Okay. We may not be too wrong. Effect of change in travel pattern, but by construction of new facilities and new network is neglected. It is related to that measure of travel impedance imply have travel impedance remain constant. So, obviously, if you the abrupt change in travel pattern by the construction of new facilities, that both are somewhat related, not exactly the same, because we are talking about the travel impedance. Travel impedance, why travel impedance will change? Travel impedance will change if there is a change in the characteristics, if you widen the road, Okay. Maybe you take say 15 travel time as your travel impedance, say for example. So, the travel time may improve if you widen the road, make a 2 lane to a 4 lane road, okay, augment capacity, or the demand reduces. Okay. Similarly, it can increase if the demand becomes more. So, the change in travel impedance is likely to happen. Of course, it can happen for other reason, but one major reason is the change in the travel pattern or change in the infrastructure. Okay. So, any impact grossly the transport network that we are ignoring. So, the main problem of the growth factor based model, or the key consideration, that it does not consider the reason for travel, right, and the basic factors are the most important factor, that is the change in the transport network or the transportation system is not linked, or the properties are not linked while you are actually forecasting the future travel. Okay. So, nowhere there is any consideration of transport network, travel impedance and anything, any related factor. It simply do something, use some multiplier in so many different ways, so that your row totals and column totals give you reasonable match, and you must have the Bezier trip distribution matrix with you, right. So, we can apply growth factor based method where there is no change in the transport network, where we need a short update, but wherever there is a change in the transport network and where we really do not have the values, right, we want to model those values, not just multiplier, using a multiplier and updating it, but we want to really model it, right. So, there we need to go for the synthetic methods. So, synthetic methods attempts to obtain the underlying causes of movement between places. Why more people are going there? Why less people are going there? Maybe the attraction is more there. If you think of a shopping, there may be more shopping opportunities available there. Okay? That is why people are going more there as compared to other zone. Or maybe the transport system is also very good. The road connectivity and the available transport system is very good. So, naturally more people are going there. So, such kind of underlying cause, why more people travel somewhere, why less people travel somewhere, okay? Why these differences are coming? This comes because of the attraction of the zones where trips are getting attracted, level of attraction of the zones, not every zone has got same level of attraction. Then the travel impedance is also not same. I mean, whatever you can take travel time, you can take travel cost, this impedance is not same. So, all these things are happening. So, the synthetic models attempts to consider these underlying causes, okay, while trying to model the trip distribution values. Relationships are established between trips and measure of attraction, as I said, generation and travel resistance. Okay. So, we are considering how much is getting generated, how much is the attraction of a zone, okay, and then what is the travel resistance. So, the underlying causes, so it is more rational, I should say more scientific as well, right. Synthetic methods can be used not only to predict future trip distribution, but also to do the synthesis of the Bezier flow. As I say that we can model even what is happening currently. So, current our impedances are known, productions are known, attractions are known. We can try to even model these values, and of course, you can check, okay, always some kind of validation is possible, but you can model it, not that somebody has to give you and only then you can apply a factor to project it as you did in the growth factor based model. In this case, we can actually do the synthesis of the Bezier flow, that is the advantage. The necessity of having to survey every individual cell in the matrix is not needed, and the cost of the data collection is also low, right, because you can do something on a sample basis, and you will understand even this more when we actually talk about the synthetic models, how we are developing. So, with this I would say that in this lecture we discussed about the one more model which are popularly or widely used under growth factor based method, that is called Furness method, and how we adjust the cells in the columns and rows to match the column totals and row totals respectively in an iterative manner, and then finally to converge or to reach to an accuracy level which is acceptable. And with one example also I explained it. Then we talked about various disadvantages or limitations of growth factor based methods, particularly highlighted the underlying cause of trip distribution, that is not considered. We do not consider the properties of the transportation network, and we said that always somebody has to give you the Tij value, then only you can apply a multiplier to update it, and there is no really physical significance or meaning to these factors, except that different way people come out, almost like different techniques or different ways of doing some kind of adjustment of the numbers. So, that end of the day the only target is whether I match my target row total and column totals reasonably. So, once you match the row totals and the column totals, we think that we have done our job. But the why people travel, what is the impact, and that brings some kind of limitations. But as I said also that there are limitations, but once we understood those limitations, we can apply the growth factor based method advantageously when those limitations are not really an important consideration in a given context. How? As I said that say maybe there is no change in the transport network at a city level does not change every day, right. Maybe some small changes here and there, but overall to influence have a big impact on the city travel, that kind of change will not happen every day. So, if you find that in last 1 year or 6 months or 1.5 year or 2 year, there is practically no significant change in the overall transport capacity of the network in the city, then we can advantageously use growth factor method to quickly update our matrix for planning purpose, which is perfectly all right. But in between, if the city has got a metro, say you did the studies before the metro was operational, and now maybe in last 1 year the metro is operating along the length and breadth of the city. Even if then it is 6 months or 1 year, still you cannot use growth factor based method, then you will be wrong. So, it has the potential, it has the limitation. You have to judge where you can apply it advantageously and where you should not apply. And then based on that we said that what are the limitations, the synthetic of the growth factor based method, the synthetic methods actually overcome those limitations. So, synthetic methods can synthesize even the Bezier travel pattern. In Bezier, each cell value we can model, not that always you have to somebody has to give, right. We can also try to model. It considers the productions, it considers the attractions, it considers the impedance or the change in the transport network. So, that is what is the scientific methods. So, with this we close today's lecture. Thank you so much.